Okay, guys, welcome. I hope the sound quality is okay here. I had to film this while I was out on the road. Um, all right, so let's talk about value-added methodology, okay? So everything that you read about for today all starts with a very basic question. And the basic question is, how do we know who is a good teacher, all right? And I should point out that this question is tied at least the way that we talk about in contemporary education policy, to the way that we pay K through 12 teachers. So it's tied to the compensation of K through 12 teachers, okay? The current model of teacher pay, K through 12 public education in the United States, teachers are basically rewarded for two things. They're rewarded for experience. So the longer you've been teaching, the more money that you make. A teacher who's been teaching for 30 years makes more money than a teacher who has been teaching for 2 years. All right? The second way that most public schools reward their teachers is through graduate degrees. All right? So in other words, if you have a master's degree or a PhD or an EDD, which is an education doctorate, in a field that is related to teaching or the subject matter that you teach, you will make more than somebody who just has a bachelor's degree, all right? This has been the basic model of how teacher salary has been determined for as long as I've really been paying attention to public education. So at least back into the mid-'80s, experience and level of education were the two primary drivers of what a teacher gets paid in every state that I know of, all right? Now, why did we decide back then to reward teachers based on these things? Well, we decided to reward teachers based on these two things for a line of reasoning that is very consistent with the way the Scouts were portrayed in Moneyball. Okay, so we did not have the ability to gather evidence on a large scale about how teachers were doing, right? Because ultimately, what you would like to do is you would like to pay teachers based on quality. Okay. I think all of us would agree, right, that we would like people who are good at their job to make more than people who aren't as good at their job, right? But we didn't really have the ability to evaluate a large number of teachers fairly for their quality, so we settled for some proxy measures, all right? We settled for some things that we could establish a strong theoretical link to teacher quality. So we can imagine, right, that all things being equal, it kind of makes sense that your experience would lead you to be a better teacher, all right? So we can imagine, right, that the longer you do something, the better off you would be, all right? Education, right? Well, you presume if you go to grad school, you learn something, and if you're going for grad school in a related field, you're going to learn something that's going to help you teach, so you'll be better, all right? And so back before we had statistics or even really standardized tests in the 80s, we thought, okay, theoretically, we think that we can measure these things very easily, and that will allow us to get some sort of measures that we think will be highly correlated with teacher quality. The problem is that we never tested whether those measures were correlated with teacher quality. Now, as data and statistics have become more advanced, we can, and what we're finding actually might be kind of surprising, right? Most studies of teacher quality find absolutely no link between teacher experience and teacher level of education and student outcomes, right? So pick whatever outcome you want. You can pick, you can pick how they do on standardized test scores, whether they get into college, whether they're more likely to drop out of high school, how they feel psychologically, all right? All of these things that we think a good teacher might be able to contribute to. Well, we've run multivariate regression studies of the type that I've already showed you guys that you guys did on the SNATS lab, all right? OLS regression, just like that in SPSS. And it actually turns out that being more experienced or having a higher graduate degree does not seem to lead to better outcomes for kids on basically any outcome that we could think about. Now, I should point out first that that is not an unchallenged finding. It is the finding, it is sort of the vast majority of the literature finds that, finds that there's no relationship between experience or education level and student outcomes. But there are some people who go otherwise. There are a couple other studies that imply otherwise. But let's think about this here, all right? How in the world can we say that experience does not make you a better teacher? That doesn't seem to make any sense, all right? Well, thing to think about, right, is think back to your favorite teacher, either a teacher in middle school or high school, or maybe even in college and things like that, all right? My favorite ever teacher was my high school calculus teacher. I just had lunch with today, more than 20 years after I graduated, all right? My high school calculus teacher was a phenomenal teacher, is a phenomenal teacher. When I had him, he was about 40, all right? And I think that the fact that he was on the younger end of the teaching profession had something to do with why I loved him so much, right? Because he was younger, he could relate to me better, right? He could more easily remember what it was like to be my age. He had similar formative experience. The way that he talked to me, the way that he taught to me, the way that he listened to me, the things that he liked about, this was a teacher who it's like, I went to a U2 concert back in the 90s with him, all right? And he'd come in and we'd talk about like the Sonic Youth Show or some other band that we both liked at the same time, all right? It's not fair to say, like, I did have some older teachers that I liked and some good teachers that I liked, all right? But I didn't have the same connection with them, right? And I think that a lot of my connection with Mike White, my teacher, was because he was younger and that he could relate to me a little bit better, all right? So you can imagine pretty easily how being a good teacher depends on a lot of things, right? And it's very possible that getting a graduate degree doesn't do much in terms of making you a better or worse teacher. It might make you a little better, but it might be that sort of, for example, good teachers are good teachers and people who aren't as good, and there's only so much that education can do to change that. And again, that's what the vast majority of the studies that we've done have found, that have shown that, look, there's no relationship between the two factors that we most commonly compensate on and student outcomes. So basically, right now, we have a system where we're rewarding factors financially that we don't think correspond with how good a job a teacher is doing, okay? Now, before we can try to change that as a society, we better have another alternative to do that. And so the first alternative that we could put out there for evaluating teachers, and remember, when we're talking about evaluating teachers, we're not talking about evaluating one or two teachers. We're talking about evaluating every teacher in a state, okay? We are talking about sort of every teacher in Virginia. We need to be able to say whether or not you deserve more money or not, all right? So we need to start to look at things. It's not feasible to have a common evaluation rubric for reasons that we can get into on Tuesday that you want, where you just sit down and observe somebody. So what we need are relatively simple to collect measurements, relatively simple operationalizations of what we think a good teacher might be, all right? The first thing that people might think, oh, what can we use that's readily available information, is standardized tests, right? Every kid in public schools in a state in the same grade takes the same test, okay? So we might say, if we were going to measure teacher quality, we might say that, okay, well, all we'll do is we'll compare standardized test scores. We'll average together the standardized test scores of all of a teacher's kids, and the teachers with higher averages are better, all right? I think the problem here is pretty easy to grasp, the biggest problem, all right? And the biggest problem is that some teachers work with kids who are harder to educate, who have more educational challenges associated with them than others. All right. So to give you this example, I'd like to compare two teachers. I'd like to compare a teacher who teaches special ed in Richmond versus a teacher who teaches regular education in Arlington. Now, in the teacher in Richmond, Richmond has comparatively low school funding. They spend about $13,000 per year on a kid. You have a lot of kids in Richmond who come from broken homes, who come from tough home situations, more proportionally than most other school districts. And when you're dealing with special ed, you're dealing with kids who have been diagnosed with a learning disability, challenging enough that they have their own individualized education plan. Okay, so all of the things, low school funding, kids from a challenging background, special education, all of these things are associated with lower test scores. All right, now let's teach our teacher of regular education in Arlington. And all I mean when I say regular education is I mean not special education. Okay, so just the normal everyday classroom that you think of, that's what this teacher in Arlington would be in. Arlington has relatively high school funding. They fund about $19,000 per year. So that means the kids in Arlington have about $6,000 more spent on their education per year than kids who go to Richmond City schools. All right. Arlington is a community with a very stable population that disproportionately has stable family lives. All right. All of these things, regular education, higher school funding, stable family lives, all of these things are generally associated with higher test scores. The point here, right, is that the teacher in Richmond can do a great job, and the teacher in Arlington can do a terrible job, all right? But the Arlington teacher might end up with higher test scores because the Arlington teacher is working with kids who do better on standardized tests as a rule. In other words, I can be a complete bum, all right? But if I work with the smartest kids in the world and we give them a test, guess what? I might be a complete bum, but because the kids are so smart, they're going to do so well, all right? Now, this is a discussion, right, of why we can't use raw test scores to evaluate teacher quality. However, there is still something to us that's appealing about using test scores because it's a statistic we already have, that we already use, that it would be easy to generate for all teachers. All right. We could also, because we'd have a standard unit of measurement, with test scores we have an ability to make comparisons across schools. So we could compare all the different schools in Richmond School District, how are their teachers, and we could compare teachers across the state, right? What would be ideal, right, is if we could use test scores and we could control for the abilities of the kids, right? So we say to teachers in Richmond, like, look, we don't expect at the end of the year, you're working with harder to educate children. We don't expect you to get test scores as high as the people in Arlington may get there, because they might be working, in Richmond you're working with a more challenging population. All we want to do, right, is we want to use the test score as a way to see if you've made progress with your kids and how much kids you've made progress from the beginning of the year to the end of the year. All right? Even if your test scores at the end of the year are low, as long as you've done a good job making sure they weren't as low as before, we might say that you did a really good job, all right, that you made progress with the kid, all right? Through statistics, we now believe that we can do that. And that's where we get into the topic for today, which is value-added methodology. So here are the 4 basic steps about value-added. Here's how value-added works for teacher evaluation. All right. Step 1, we use previous year's test scores to establish a student's ability level and prior learning. 2, then we see how much a student gains over the course of the year. 3, we use regression analysis and a data set that contains all students from multiple years. We can say this is how much we believe that if this kid had a typical experience, they should have gained. Okay? Then we can compare each kid's actual gain to the projected gain. All right. If a kid exceeds his expected gain, we assume his teacher did a good job. Now, that's a lot to throw at you at once. Let's see how it works in practice, okay? I've got an example here. All right, and let's start here.
Okay. Conference call.
So I zoomed in a little bit, all right? Now, what you have here is a situation in which we have a data set, right? And you can see here I have student IDs, I made this data set up, and I have these ... here. This could contain, we're imagining a data file here, where we contain information on every student, every fourth grade student in Virginia, all right? Every fourth grade student in Virginia. So we have a big old data set. We have like 300,000 lines in our spreadsheet, all right? This is a kid, right? Kid number 1. We have his fourth grade reading score for 2014. You can see that he scored 397. We can also see that he scored 352 on his third grade reading test. So this is a third grade reading test score. This is a fourth grade reading test score, all right? And then we have some other variables, right? We have, where did the kid go to school? Where did the kid's race and ethnicity, the kid's gender. We can have any variable in here for which we can have information, and that becomes important when we start to think about this in terms of a statistical approach. All right? So, here's what we're going to do. All right? We're going to make, and this is a regression very, very similar to what we've already done, to what you do in SPSS when you go into analyze regression linear. It's all basically just a variation on that process, so you know what this is. This is our dependent variable, all right? So we say that we're going to try to predict for a kid which factors contribute to how he did on the fourth grade reading test, all right? The key independent variable is going to be the third grade reading test. All right? So in other words, we're going to say, now let me finish this because I got a PowerPoint that will make the point more clearly here in a second. All right? The dependent variable is fourth grade reading, the key independent variable is third grade reading. Then we have all these other variables that are controls, right? That are things that we think might affect student learning. So we have found, right, that women and men learn differently at different rates in different ways. So therefore, we might say, okay, we want if we think that might matter to how a kid does on his fourth grade reading, we're going to throw it in there. Same thing with race and ethnicity, right? We might throw that in there as a control. Same thing with where the kid goes to school. You can have any controls here that you want, all right? And what you end up having, remember how we talked about how y equals mx plus b? So that's basically what we have here, all right? We've got the 2014 score, which is our y. Then we have this beta sub 1, which is just the m, which is, you know, this is a simplification because it's multiple variables, but it's the m, the slope of the line, times the 2013 score. Well, you remember, right, that if we go down here, what I've done is I've simulated an SPSS table, right? Because this is exactly what they look like. And so what we'll do is we'll do that, right? And the dependent variable is the 2014 score. And you need to, we're seeing what these 4 factors and any other factors we want to throw in, how much they influence what a kid got on 2014. All right, so the first thing we do is we check for statistical significance. We say, oh, okay, the school that you got to, and I made these results up, you won't get it if you do the data. But you can see right here, right, we check statistical significance. Okay, that factor doesn't matter, we're going to ignore that factor. All right, but we see that the 2013 score, the race, the gender, that they're all statistically significant factors. All right, so that means that we can then look at their unstandardized coefficient and use that to figure out how much a 2013 score has an effect on the 2014 score. all right? In other words, where is it? Oh, I want to go back here, right? You can see here in my spreadsheet that I have added another column, all right? Based on the regression equation, all right, we can predict what the kid would get, is supposed to get, right? So remember that the regression equation is going to pick up trends for all 300,000 kids in our data set. It's then going to tell us, all right, what is the impact on average, right, of a third grade reading score on our dependent variable? What's the impact of average on a student's race, of gender, stuff like that? Well, we can then use the slope of the line and multiply it by each kid's value and come up with a score that we think, based on the trends in the data set, the kid should have gotten, all right? So this is what we think the kid should have gotten, all right? But remember, we know from our discussion of R squared that a regression equation is not going to explain everything, right? This score is not going to be directly equal to what the kid actually got, all right? So let's look here at kid number 1. You can see that kid number 1 got a 397, right? He was only projected to get a 373. Oh, it's a she. So she was projected based on trends. Based on trends, we say quantitatively she should have gotten a 373. But look at this. All right, she got a 397. That means that this kid scored 24 points better than expected. All right? Now, what value-added methodology assumes is that if a kid scores better than expected, if the kid exceeds its projected reading scores, it assumes that the teacher did a good job with that student. All right? And from that, we can see how a teacher did with all their students and decide if we think that that teacher did a good job based on whether they had a lot of students that exceeded expectations. Okay? Now, how do we evaluate this method? Is this method any good? Okay? I do think that this method is pretty good. All right? I think that statistically it works out really well. There's a but here, all right? And I will tell you, like, I'm a supporter of value added. I think that value added does a good job for part of teacher evaluation, or at least it can be, all right? However, there are some things that we need to think about before we start saying, oh, value added has solved the whole teacher evaluation problem for us, okay? Problem number 1 is, so let's go back to these test scores right now, all right? Value-added methodology and the statistics that I just showed you, it works with the existing test scores, all right? So the math all works. What value-added cannot tell us is this a good test, right? Is the test that we came up with, is it a good measure of what a student is supposed to learn, right? Because you and Guy, we can go all day long, right, and talk about whether or not, okay, can the standardized test actually measure anything? Or is the standardized test not capable of measuring student learning at all right? So the important thing to remember is that our value-added rankings are only as good as the quality of the test that gets the information from students. So in order for value-added to work, we have to have good tests, okay? Number 2, you can see in this list of factors here, right? We have excluded a lot of factors that potentially could influence how a kid did on their 2014 test, right? We could think of sort of like, is the student on free and reduced lunch? We could think of whether the student suffers from depression or not. We could think about whether or not the student has to walk an hour to school every day. All these different things, all right? But that means, right, that we may be suffering from omitted variable bias here, that our model's only as good as the thing. Well, look, we're using what's called the residual over here. We're using this stuff, and we say that everything that our model doesn't account for is teacher effects. All right. Now, unless we have a pretty good model that can control for a lot of different things, we risk saying that a teacher is good when really maybe it's just because of things that are excluded from our model. Third problem. All right. The third problem is how much can our evaluation of a teacher be reduced to what a student does on a single test on a single day, right? So I'll tell you what, Mike White, he was my calculus teacher, and he probably helped me. I did really well on the AP test. I did well in calculus in college, all those things. But that was like the least he did for me, all right? Mike White helped me develop as a man. He helped me become more confident. He helped me express myself better. He believed in me, and because he believed in me, I started to believe in myself. None of that stuff may show up on a kid's standardized test, or at the very least, the standardized test is not constructed to directly measure that thing, all right? So if we are going to base our evaluations of a teacher solely on this number, right? We miss sort of like the soft factors that we think are actually really important. And I call them soft factors not to denigrate them, right? I think that's the most important thing that a teacher can do is instill confidence in a kid, help a kid believe in themselves, teach them how to be an adult and stuff like that. Maybe this gets at some stuff indirectly, but directly all it measures is how a kid does when they sit down for one test one day. All right. For that reason, I love value added, and I think that it can be a valuable piece of teacher evaluation. However, I do think it has to be part of what we call multiple measures. So the move in education right now is to say that, sure, we can evaluate teachers a little bit due to value added, right? Because we think that this measures some good stuff, and we think that it's relatively objective in the fact that we treat everybody just as the function of their test scores. But that can't be the only way to evaluate teachers. You still have to leave room for a principal sitting in a class or an observer and saying, like, do I see this kid as a good teacher? You still have to make room for sort of like, okay, maybe they're not as good as on math skills, but they're helping these kids grow up. They're helping them mature, okay? So ultimately, and we can talk about this on Tuesday, the other ways, the other forms of multiple measures that go along. Basically what I'm saying is this value-added score in the systems that I like anyway is only one part of a way that can tell us something about whether or not a teacher is good. But I do think it can tell us something relatively important. So we'll touch back all on this on Tuesday. Bye.